This one, let's talk about the Klein 4 group a bit. It's denoted K4, and yeah, we talked about it before, but today let's talk about one concrete case. It's representation by matrices. We can represent it by 2 by 2 matrices. That's interesting. So K4, it's also denoted V sometimes. That's just notation. But as far as being able to represent it by matrices, the elements, so there's 4 elements. So we have the identity, and then we have 3 other elements. We can call them, for example, A, B, C. So these 3 elements, they are not identity, will, for example, be these matrices. 1, O, O minus 1. B would be, I mean, we can change the order of how we name them. It doesn't really matter that much, but the property should be retained, same. And C can be this one. So these 3 matrices, of course, they're invertible because otherwise we couldn't have it as a group. And namely, they're inverses of each of themselves. So A squared equals E, B squared equals E, and C squared equals E. And E, like it is with when we have a group that contains of matrices, so we've denoted these 3 elements, and the 4th element of K4, because K4 has 4 elements, is going to be the identity matrix. So here we see all the 4 elements of K4 represented by this group of 4 matrices. So this is directly isomorphic to representing K4 as, for example, those well-known 2 tuples 0, 0, 0, 1, 1, 0, 1, 1, or other ways, because there's many ways we can denote K4. But we see this works out. We can actually explicitly look at it, so we can see that 1, 0, 0 minus 1. Well, that's A. When we multiply by B, it should give C. So times minus 1, 0, 0 minus 1, it should give C. So C is this. Well, let's do the multiplication of row and column. Then we minus 1 here. Then we have this by the second column. That's 0. For the second one, we have 0, and here we have 1. So yes, it does work out. This is C. So we got A times B equaling to exactly here the C. So that's how Klein 4 should work out. The same will go if we multiply B, as we did. B and A gives C, C times B gives A, and of course this is acting abelian. So 2 of these, A, B, C, will give the third one when multiplied. The thing is with E, of course, nothing is changed, just like with an identity matrix. And we could analyze deeper into it, but I think these are the most interesting things to note about this topic of K4 as matrix